Today we're continuing on with Go Math, and we're doing Go Math lesson 11.3. And our learning goal is I can classify and compare quadrilaterals. We already know that quadrilaterals are polygons with how many sides?
4.
How many vertices? 4. How many angles? 4. Good. So all the quadrilaterals in the world have 4 sides, 4 vertices, and 4 angles. But today we're going to learn some of them are special kinds of quadrilaterals that have different names. So they're quadrilaterals, but they're something more specific as well. Does that make sense? Good. At the top of your Go Math packet for 11.3, you will see this question. It says, unlock the problem. Okay, sorry. It says, a seating chart for a baseball field has many 4-sided figures. So if you take a look at this picture, you can see this is a baseball field seating chart. This is the part where the players play, and all these different areas are where people could sit. Okay, the numbers represent, like, on your ticket, it would say, oh, section 112, then you would sit here. Or section 148, and you'd be sitting here. Do you see that? Okay. Now, each of those sections have 4 sides. Do you see that? Each one has 4 sides. Now, just because they all have 4 sides, 4 vertices, and 4 angles, do they all look the same? No. Down here are these ones, by the way, quadrilaterals. They're what? And you can see some triangles over here, too. But what about, look at section 152. How many sides does it have?
4.
Good. So it makes it a? Look at section 150. How many sides does it have? 4. How many vertices?
4.
How many angles? So that makes it a quadrilateral. But look at how 152 and 150, they look so different, don't they? But they're both quadrilaterals. The question that we're going to study to be able to answer is what types of quadrilaterals we can find. As we know, all polygons that have 4 sides, 4 angles, 4 vertices fall into the big, broad category of quadrilaterals. Okay? But there are special types of quadrilaterals that we're going to learn about today. There are 5 special types of quadrilaterals that you need to memorize. You can classify quadrilaterals by their properties, such as parallel sides and perpendicular sides. Okay, take a moment right now to underline the words parallel and perpendicular. Let's talk about what those mean. Parallel lines are lines that are always the same distance apart. So if I have a line like this, and I want another line to always run the same distance, it means that from here to here, it's the same distance as from here to here, from here to here, from here to here, if the lines were to keep going. They never cross. So I want you to write parallel lines are lines that never cross. Think about it. If I have 2 lines and one line is going like this, and one line's going like this, are the 2 lines always the same distance apart? No, they're getting closer and closer and closer. So the yellow lines are parallel because they never cross and they're always the same distance apart. The red lines are not parallel because they're not always the same distance apart. They're getting closer and closer and closer until eventually they cross. Does that make sense? Now, perpendicular lines are lines that intersect to form 4 right angles. So if I have a line like this, and I make a line like this, you can see it makes 1 right angle, 2 right angles, 3 right angles, and 4 right angles. So perpendicular lines cross to make 4 right angles. All polygons that have 4 sides and 4 angles are called quadrilaterals. That's like the broadest category there is. As long as it has 4 sides and 4 angles, it can be put into the quadrilaterals category. Okay. Now there are special types of quadrilaterals. A parallelogram, this is a parallelogram right here. Okay. So if I look at the parallelogram, I can see that it has its opposite sides. Opposite sides mean this one and this one, or this one and this one. Opposite means they're opposite from each other. What do you notice about those opposite sides? They are all congruent, and they're all what? Good. So a parallelogram has opposite sides that are parallel and congruent. A parallelogram is anything that has opposite sides that are congruent and parallel. Well, if I look at my rectangle, are the opposite sides congruent? Yes? Are the opposite sides parallel? Is it? So a rectangle is also a parallelogram. Is a rectangle also a quadrilateral? So how many different names can we name this thing so far? 3. We can call it a quadrilateral. We can call it a parallelogram. We can also call it a rectangle. Can we call this one a rectangle? And we're going to learn why. Because a rectangle is a special parallelogram with 4 right angles. Do you see them? 1, 2, 3, 4. And it has 4 pairs of what kinds of sides? What do you notice the lines of the sides are? They're all, what is it? They're all what? Are they parallel? Look at the 4 sides. How do they meet? What kind of angles do they make at the vertices? Right angles. So what do we call lines that meet and make right angles? So a rectangle is a special parallelogram with 4 right angles and 4 pairs of? You got it. Fill it in. Let's talk about this one right here. Is it a quadrilateral?
Yes.
How do you know it's a quadrilateral? Samar?
Because it has 4 sides and 4 angles.
4 sides and 4 angles. And 4 vertices. Nice. Is it also a parallelogram?
Yes.
Give me a thumbs up if you think it's also a parallelogram. Or a thumbs down if you don't think it's a parallelogram. Jan, why do you say it's also a parallelogram?
Because, at first I thought it was because it looked like it would be like the same, and our opposite sides were all equal.
Okay. So our opposite. So we know that a parallelogram needs to have opposite sides that are congruent. For this figure, are the opposite sides congruent? How do you know they're not?
Because all the sides are like the same. Like,
All 4 sides are the same? How do you know all 4 sides are the same?
Because instead of showing like the 2 lines to show that these 2 sides
Yeah.
are parallel, it has. Like,
So let's talk about that. We noticed, do you guys agree that all 4 sides are congruent based on the tick marks? So a parallelogram needs opposite sides to be congruent. Are those 2 opposite sides? Yes. Are they congruent?
Yes.
Okay. Are these 2 opposite sides?
Yes.
Are they congruent?
Yes.
So does it satisfy the requirement that all opposite sides are congruent?
Yes.
Okay. We also need the 2 opposite sides to be parallel. Are the yellow lines parallel?
Yes.
Are the green lines parallel?
Yes.
So is this a parallelogram?
Yes.
Oh, interesting. Okay. Is it a rectangle? Why or why not? Why is it not a rectangle? Or why is it a rectangle? Priya? They don't form, there's no 4 right angles. There's no perpendicular lines. So we call a rhombus a special type of a parallelogram. By the way, the answer was there. It is a parallelogram. Because it has how many congruent sides? 4. So let me ask you a question. Can a polygon be a parallelogram and also a quadrilateral? Okay. Can a polygon be a rhombus and also a quadrilateral? Can it be a rectangle and a parallelogram? Can it be a rhombus and a parallelogram and a quadrilateral? Can it be a rhombus and a rectangle?
Yes. No. No.
Can a rhombus also be a rectangle?
Yeah. No.
For the definition of rhombus, does it say it's a parallelogram that has no right angles?
No.
Can a rhombus also be a rectangle? All it needs to have is 4 congruent sides. Is there any sort of rectangle that could have 4 congruent sides?
Square.
Yes, the next one is called a square. A square is a special parallelogram with how many congruent sides?
4.
We know about, right? They have 4 congruent sides. And so by definition, that means it's also a rhombus. Do you agree? And how many right angles does it have?
4.
1, 2, 3, 4. Okay? Let's consider the square for a moment. And let's see if it applies to all the terms we've learned thus far. Okay? Can a square also be called a quadrilateral? Why? Because it has 4 sides, 4 angles, and 4 vertices. So it's a quadrilateral. Could it also be considered a parallelogram? Yes, because opposite sides are congruent. Do you see that? And opposite sides are parallel. Okay? Could it also be considered a rectangle? Yes, because it has 4 right angles and it's a parallelogram. Could it also be considered a rhombus? Yes, because all 4 sides are congruent. So a square is something that can be called a quadrilateral, it can be called a parallelogram, it can be called a rectangle, and it can be called a rhombus. Okay, does that make sense? A trapezoid is a quadrilateral that has exactly 1 pair of parallel sides. So can a rectangle also be a trapezoid? No, because a rectangle has how many pairs of parallel sides? 2. Is a trapezoid also a parallelogram? Is it? How many sets of parallel sides does a parallelogram need to have? 2. How many can a trapezoid have? So can a trapezoid also be a rhombus? Can it also be a square? No. We can think of this like two families. Okay. The parallelogram family includes rectangles, squares, rhombuses. Okay. Whereas the trapezoid is kind of an outcast because it's the only one that only has one set of parallel sides. Parallelograms, rhombuses, rectangles, and squares all need to have at least, or not at least, they need to have exactly 2 pairs of parallel sides. Does that make sense? Okay, and then quadrilaterals, this is like the term that fits all of them. So if you can think of these polygons like they're trying to go to different houses. The parallelogram house will accept any polygon that has 4 sides, 4 vertices, and 4 angles. So which house will accept the most number of polygons? Quadrilateral, parallelogram, rectangle, rhombus, square, or trapezoid? Very good. Okay, basically as long as you have 4 sides, you can go to that category, that label. Okay. Parallelogram is pretty broad too. As long as it has 2 pairs of parallel sides, it's a parallelogram. Then when you start to look at the angles, you'll consider if it's a square or rectangle, right? If it has 4 right angles. And then if all 4 sides are congruent, then it's also a rhombus. Does that make sense? Good. A rhombus compared to a square. So look at your Venn diagrams. Is a rhombus always a square? Is it sometimes a square? Yes. Is it never a square? No. So a rhombus is sometimes a square. What about a parallelogram? Is a parallelogram sometimes a rectangle, always a rectangle, or never a rectangle?
Always. No. Sometimes.
Is a parallelogram, if I draw a parallelogram, will it also always be a rectangle?
No.
Will it never be a rectangle?
No.
Will it sometimes be a rectangle?
Yes.
Okay. If I draw you a rhombus, well, can I also call it a parallelogram?
Yes.
Sometimes? Or all the time? Is a trapezoid, if I draw you a trapezoid, can we also call it a parallelogram sometimes?
No.
Always?
No.
What should I write? What about a square? If I draw you a square, is it going to be a rhombus too? Sometimes? Always. Very good. Okay, so again, this is the kind of skill you need to have. If you just copy my words right now, does that show you know it? No, you need to practice this.